morning, Pure fans. Thank you so much for coming and joining us these few days in Las Vegas. Is it hot enough out here for you? On our way in, 110 degrees, smoking, right? And that's what we hope that we're doing here in Las Vegas. Is we're really smoking with with everything that we're doing in data storage. So first of all, like Lynn, I want to thank everyone for coming in, all of our customers, our prospects, our partners, our press and analysts that are here with us today. Too many to mention, but we really are very honored by you coming out all this way, taking your time to spend with us. And we hope that you come away from this feeling more enthusiastic than ever. Certainly we have. It's because of you that we, Pure, have grown consistently every single year. The fastest grower and in some ways, the only grower in enterprise data storage. Consistent growth every year, the only Western vendor to grow every year. And that's what's catapulted us now to $3.2 billion in total sales, very profitable, 17% operating profit. Another statistic that might be surprising to some, we're almost 50% now of revenue in our subscriptions. This is Evergreen Forever, as well as Evergreen One, and an increasing percentage of our sales going as a service with Evergreen One. And then the number that I'm most proud of, and that really sets us apart from every other vendor, is that we will spend, even this year, more than 20% of our revenue on R&D, and if measured on a GAAP basis, over 25%. And it differentiates us because it's Pure that has always considered data storage to be high technology and not a commodity. And that's what's allowed us to stay number one in innovation in data storage. And as you'll see on this Gartner Magic Quadrant, yet again, this year, number one. What was different, though, in this year is this is the first Magic Quadrant that measured data storage platforms. And they put us again as number one in data storage platforms. And it's because of our very consistent, very advanced, and reliable data storage system based on Purity. So you might ask, okay, we spend 20% or more on R&D. What has that gotten us? What has that gotten you? And I would say that we've reinvented storage in many different areas. We've reinvented storage, for the cloud. We've reinvented storage, we believe, for AI. And we're, again, reinventing storage for enterprise, especially in this new era of data. All right, so let's talk about AI now. Purity, again, is the basis of what we're doing in the AI space. We've just introduced, and we are now, as of this show, going general availability on our newest FlashBlade Exa product. FlashBlade Exa is just another variation, if you will, hardware variation of our FlashBlade product. FlashBlade, of course, very, very fast file and object storage, where we provide both the protocol support as well as the storage inside FlashBlade. Well, with an update to Purity, now FlashBlade can operate disassociated with separate data nodes. And by operating with separate data nodes, we can increase the overall performance of the FlashBlade product. As a matter of fact, FlashBlade, as well as FlashArray, is the fastest metadata, uses key value store to create the fastest metadata engine in the world. And by extending it with additional data nodes, we can allow parallel performance for access for high performance data, such as for AI. And then, by adding additional metadata nodes and additional data nodes to that, we can consistently increase in a linear fashion the overall performance of FlashBlade Exa. And this linear performance we've proven now over the last several months. And it just keeps getting more and more performant as we add metadata engines and data nodes. This is completely, as we introduce it today, it'll be 5 times faster than anything else in the world at high performance AI for large scale systems. And because it's based on Purity, we're now able to scale all the way from FlashBlade S, which many of you are using today, that can already handle many tens, if not hundreds, of GPUs in a cluster for AI performance. But for those of you that may worry about scaling to thousands of GPUs, if not tens of thousands, FlashBlade//EXA can take you all the way up to 100,000 GPUs. And then with Meta with a different type of architecture will be using our DirectFlash technology, as I spoke about before, for even larger scale environments. So again, the promise of Purity plus Evergreen, we provide you again the ability to scale non-disruptively from the smallest workloads to the largest, from lower price all the way up to the highest performance. Now let's talk about AI though in the real world, in the enterprise world, where AI, you don't worry about necessarily going to 100,000 GPUs. How many of you are going to be going to 100,000 GPUs in the next year? I thought so. It was the only question I've ever asked on stage where I didn't expect to see any hands. So AI in the enterprise space, we think we all believe that AI is fundamental change. It's changing our jobs, it's changing the jobs of our colleagues. It's going to affect really every aspect of IT, job categories, workplaces, workflows. Knowledge workers are going to be disrupted. But one of the things that I think is interesting to think about is that AI is going to change the relationship between software and data. If we think about the last decade or two, it's really been software that's been eating the world, right? That's what Marc Andreessen said. Software is eating the world. Data was necessary, but software was the key. And let's just think about ride sharing, right? That's been a big disruptor. We used to take taxis or black cars when we would go from one place to another. Now everybody does ride sharing, right? Except, if you go to San Francisco today, do you know that more rides now are taken in self-driving taxis than by rideshare apps? It's pretty amazing, right? Well, what's a self-driving taxi? What's a self-driving car? It's all based on data. It's been trained on data, and the quality of data is what's made the difference. And that's the difference that AI is making, is that the data is becoming, in some ways, more critical than the software itself. And that's so as we, as workers that work with data, look at our lives going forward, look at what's important for us going forward, we're going to be data-centric. So let's talk about how data is kept in the enterprise. Let's look at an enterprise data and enterprise data center architecture. So if we go into a data center and we start building a new app, or we start accommodating a new type of app, let's look at, for example, a new database environment, right? Well, you start with compute, the software that goes onto a compute node. And then, of course, you're going to add storage to it and a network to connect it to everything else. And this is a stack, right? Now, the server may be virtualized. You may have a VM, or more modern, maybe going to containers. But typically, the storage is direct connected to the application stack. Could be, of course, more than one server, but it's dedicated, it's sized, it's managed. If it's Fibre Channel, it's literally directly connected to the application itself. And then you build another application, or you accommodate another application, and that has its stack. And another application or backup, and it has its stack. And each of these environments is separate from one another. And if you look at that and look at the way that the data storage is managed, well, the arrays are managed individually, right? And the setup, the provisioning, is one by one. You cannot share the capacity between two arrays. You can have two database apps right next to one another with different arrays. One array can be full, one array is only partially full, but you can't really share the capacity between them. They've been designed specifically for their application environment. Your servers may be virtualized, but your storage is not, right? And governance is array by array and highly manual. So that is your snapshot policies, your backup policies, your resiliency policies. You are configuring that array by array. Now, that's looking at it from a storage standpoint. Let's look at it from a data standpoint. The data itself is captive to the application stack. Two ways to get access to it. You can copy it, or you can go in through a set of connectors through the application. You have poor records of data copies and movement. I know this for a fact because we've seen it everywhere. Anybody can copy the data, go somewhere, no records kept of it, right? Any records are manual. The raw data itself is inaccessible to other applications. Again, you have to copy it to get access to it. And data governance is inconsistently applied to these environments because it's applied manually by people in different areas. And exactly what has been put into place is rarely standardized. If it's standardized on paper, but not in software. So let's compare this to the way clouds operate, right? What is the architecture in a typical hyperscaler? Very different. First of all, it starts with, well, we could start in multiple places, but let's start with the compute layer. They have a layer of virtualized compute, right, that can be assigned, in software, right? But similarly, they have a layer of storage. That layer of storage is the same across all of the software environments. It's also virtualized. Now, they may have multiple different layers of storage. Those layers are really qualified by price performance. They'll have a high performance tier, they'll have an archive tier, and they may have a couple of tiers in between that represent price performance layers. But outside of that, it all looks the same. And it's shared across all of their application environments, all across all their customer application environments. And you get access because it is coordinated through a management layer that assigns how different storage or how different compute is assigned to different application workloads, right? And think of it as, instead of full stacks, which are sort of hardware, they are virtual full stacks, right? Which is all based on software. So let's just compare these two for a minute. The enterprise architecture and the cloud architecture. Enterprise storage architecture is vertical stacks. Whereas cloud storage architecture is horizontal, right? It's a common layer that is assigned in software. Enterprise storage architecture is highly manual. Cloud storage architecture is fully automated. Enterprise storage architecture creates data silos. The data is captive to the application stack, whereas cloud storage architecture creates accessible data pools because, assuming the appropriate role-based access controls and security, it is physically accessible to other applications, which makes it easier to get access for things such as AI. So I think of enterprise storage architecture as being physical, whereas I think of cloud storage architecture as being virtual. And so this thinking has inspired Pure to say, well, how can we make the enterprise data storage architecture that exists today to look more like a cloud architecture? And this is our vision for what we're calling this new era of data. It is a new era of data where data is becoming more dominant relative to everything else. Our jobs of managing data is going to be critical to the success of our organizations. And so as we look at that, we think of it as requiring a much more consistent environment, a much more automated environment for data. And we think that in order to do that, it starts with a consistent software layer, which we call Purity. Now, Purity, it provides block, file, and object. It does so at every different price performance level. And we're able to do that because Purity at its heart is just a giant key value store that is able to handle any type of data as a key value store. So it's very fast, block, file, and object are all handled in a very similar way. And of course, we have built in all of these ilities, if you will, whether it's resiliency, it is upgradability, it is the evergreen capabilities. We've built that all into Pure. And we've put it into a platform that is really quite extensible. So we think of this, it's common operating properties, it's the evergreen capability, and all of these capabilities are built into it. And the fact that we can now scale from the lowest price, from even getting to the same TCO as hard disk environments, all the way up to the highest performance in AI, as well as with all of these ilities that are built into basic Purity. This is what we mean by a unified data plane. So in order to better manage your data in an enterprise environment, you need to start with a unified data plane. But the key message that we're bringing to you today is we've added something that is very new and very different. All of this, sorry, I got ahead of myself. All of this is managed by Pure1, all of it available as a service, and all of this able to manage all of your different workloads, whether those are your enterprise apps, the traditional apps, VM-based apps, or whether these are new apps that are based on containers, AI, and ML, or the latest in terms of Kubernetes virtualization, which we provide both with Purity as well as with Portworx. Now, the big reveal, sorry about that, is the new thing that we've added is this new capability we call Fusion. And what Fusion does is create a new intelligent control plane. So for those of you that have ever been in a network, you know what a control plane does. It allows individual, in the case of communications, routers and switches to operate as a network. What we've done is we've allowed all of our individual arrays to operate as a cloud of data, an enterprise cloud of data. It allows all of your arrays to be managed as a fleet, but more than that, it allows you to define how you want your different data categories, your different data sets to be managed on a global basis. This is not about clusters. It's not about just allowing a few arrays to operate together. This is about a global data cloud with different availability zones and regions that you get to define, and that will then apply your global governance and compliance standards on a global basis and operate on that data automatically. You define the policies, that all gets set automatically. So let's just look at those two things, the difference between individual arrays and an enterprise data cloud. And individual arrays are manual. They require manual provisioning, whereas a data cloud is auto-provisioning. You go from a defined capacity and performance on a per array basis, and you go to shared capacity with auto load balancing across them. So it saves you money. You go from manual governance to software-based global cloud governance of different data sets that you define. You go from the protection that you have to set up manually, array by array, to protection that is then done by the policies that you set. And you go from data that is captive to the arrays to data that can now, with the appropriate governance and authorization, to be basically accessible by any application. And this is what we mean by you being able to build your enterprise data cloud. It means going to a virtual cloud of storage rather than dedicated storage per array. It means going to a consistent environment across your global network. I know how that operates. We all know that we are not consistent on a global basis, maybe not even within a single data center environment. You go to automated data governance. Automated, think of that. You set up the governance, and if you ever change your compliance standards or your governance standards, instead of having to go to every single array and make changes, you just change the presets and it happens automatically. You go to built-in cyber resilience because it just becomes part of the preset rather than doing it again, array by array. And then finally, you become software defined. You become software governed, and you provide a global scalability of your governance standards. This is a major change, not just in the way you manage storage. More importantly, it becomes a major change in the way you handle your data. So the way to think about this is when you build your enterprise data cloud, you can start to stop managing your storage and you can start managing your data on a global basis. So we have 3 speakers that are going to take you through every element of this. We have Chad Kenny, that is going to be taking you through this concept of an intelligent control plane and what it does for you at many different layers. Rob Lee will give you all of the updates on that unified data plane, because if we don't support all of your different use cases and workloads, of course, it doesn't really become a full enterprise data cloud. And then we're going to have Naveen show you how this can be done as a service for you, so that, in fact, we do most of the work and not you. So I want to thank you for your time, and I hope you enjoy, and I'm sure you'll enjoy, the rest of the show. Thank you.